Hi, I'm Nathaniel Helmenack. Thanks for taking the time to view my research into sandstone. Properties of materials are descriptors of their behavior. Through the classical mesoscale conservation equations of mass, momentum, and energy, provided we know the phase space of a material, we can anticipate its behavior. We use constitutive strength model relations to model a material's ability to withstand, yield, or fail under an applied load. Simple models like von Mises are sufficient in most cases. However, materials also have hydrostatic dependence, and the strain rate and temperature at which one loads a material affects its strength as well. Combining these ideas means that to nominally describe a mesomaterial, one needs to characterize its properties and strengths under a range of different strain rates and loading conditions. Given Marquette's dual diaphragm gas gun, we have a unique ability to conduct both material property and biaxial material strength testing of a heterogeneous material. Sandstone. SiO2, the compound which makes up the majority of sandstone, is a compound of interest given its high abundance in nature within mesoscale structures of various porosity. By studying the pure SiO2 within sandstone, it is easy to compare with other common structures such as solid quartz, quartzite, sand, and aerogel. These material properties are important to model geological events on Earth, including earthquake modeling, mining and fracking, design engineering for both human and natural disasters, and momentum enhancement to characterize, mine, or deflect large celestial bodies. Before testing the material, work was done to cut, lap, machine, and characterize the sandstone, describing the material's grain size distribution in addition to chemical composition, initial density, porosity, shear, and bulk modulus. As the material was mounted within several testing targets made of high-strength steel and aluminum, testing was likewise done to these materials before the target was fully assembled, checked twice, and shot. In the uniaxial test, compression waves are sent through a material, compressing the sandstone, while a sensor behind the sandstone measures the surface velocity in the axial direction. Through uniaxial experimentation, we find descriptors between density and pressure, in addition to material strength properties. This experiment also served another purpose. As for future experiments, it is imperative to understand the thickness of a heterogeneous material necessary to make bulk material property assumptions. As we increase sample thickness, the material reaches its measured state more quickly and for longer than thinner samples. Of novel interest is the strength of sandstone under biaxial loading, which provides a clearer description of material strength. The oblique pressure shear experiment relies on loading a sample in compressional equilibrium before a transverse shear wave arrives. Because of this, it is important that the sample is as thin as possible, a challenge when characterizing heterogeneous materials. Therefore, by relaxing to only 90% of equilibrium, full-size sandstone samples of 2 mm nominal thickness are under construction to characterize the sandstone material strength under pressure shear. Once materials have been shot, we hope to have the following results: insight into the necessary heterogeneous sample thickness needed for accurate properties, better understanding of high strain rate, uniaxial strength and material properties, and finally, strength properties of sandstone under pressure shear loading.
But yeah, tell me over and over and over again, my friend, how you don't believe we're on the eve of destruction. Don't you understand what I'm trying to say? And can't you feel the fears that I'm feeling today? If the button is pushed, there's no running away. There'll be no one to save with the world in a gray. Take a look around you, boy. It's bound to scare you, boy. And you tell me over and over and over again, my friend, how you don't believe we're on the eve of destruction. Think of all the hate there is in Red China. Then take a look around to Selma, Alabama. You may leave here for 4 days in space, but when you return, it's the same old place. The pounding of the drums, the pride and disgrace. You can bury your dead, but don't leave a trace. Hate your next door neighbor, but don't forget to say grace. And